So what we are going to cover this afternoon is basically split into two blocks. First block is about accelerators. Fundamentally, what kind of research do accelerators enable will be the topic of the first talk. That will be followed in the third talk by an insight into how particle physics can not only help us explain the fundamental laws of physics better, but also help us to move back in time to the very beginning of the universe. Second half of the afternoon, after the break, we'll focus more on lasers and light sources. So we will look into how accelerators can be the basis for ultra-fast science. We're talking about attosecond time resolution, so that's the millions of a millions of a millions of a second, where we really want to explore and see what actually happens in nature, such as unfolding of proteins and similar processes. Now, in between these talks, there will be many talks on applications. I mentioned medical applications already, which will be the subject of our second talk. And these are my little islands here. That's where the water is a bit rougher, and that's where the journey also gets extremely interesting. And you will see a number of applications beyond the fundamental physics that really are of immediate benefit to society. In energy, in security, in the health sectors, you will find all of these this afternoon. What's also interesting, you will see that most of the research related to accelerators started some 50 years ago or even longer. But really, there's still so much more to be done. So there's this undiscovered territory that's where we don't know the answers for, and where accelerators, I believe, will be fundamentally the tool to use for future discoveries. Now, in addition to exciting research, accelerators are also perfectly suited for researcher training. And that's really what brought us together here today, because this year we are celebrating the end of two very large European projects. As you've just heard, OPAC and LACubeNet, which are coming to an end at the end of this year. And both networks are funded within the Marie Curie actions as part of the 7th Framework Program of the European Union. They are very large international collaborations which have trained 45 students over the last 4 years. And I hope you enjoyed the poster session this afternoon and talking to our fellows, understanding what they have been doing, why they moved from one country to another, halfway around the world in many cases, to study accelerators and why these are so interesting. I've just picked two examples here. Marcin, who is based at CERN, shown how he's mounting one of his cryogenic beam loss detectors, and Alexandra, originally from Russia, who's based at the Cockcroft Institute just 20 miles away from here. And she's using lasers to measure the movement and velocity of various targets, solid targets, fluid targets, and gaseous targets. Now, their research projects are really high-tech projects where they have become an expert over 3 years in a very specific area. However, if you look at their broader skills that they have acquired during their training, you basically come across all these disciplines. So our message today is, if you are doing research in accelerators or lasers, what you ultimately also get is training in all these different topics. You learn about physics, about engineering, about IT, about mathematics, data analysis, and what better basis could you have for your future career as a researcher, independent of whether it's in industry or in the academic world. So accelerators are not only exciting tools for discoveries and for applications, but they're also perfect for researcher training because you get such a diverse set of skills basically automatically built into your research projects. Now, our two projects, as I said, they are very large Marie Curie networks. The first one, LACubeNet, is a network on laser applications at particle accelerators. So here we really join for the first time two communities that normally are quite separate. We join the laser guys with the accelerator community. Both are using resonant cavities. One is focusing on optical cavities, the other guys use radio frequency, and we join them together in just one network. And we looked into how can we create better particle beams by shining laser onto metals, for example, to create electron beams. How can we create better ion sources by using lasers? We also looked into how can we accelerate better. How can we go beyond the limits, the technical limits of RF technology? How can we use a laser to push a cloud of ions with an accelerating gradient that is 100 times, maybe 1,000 times larger than any accelerating gradient you can generate at the moment? And also what we did in LACubeNet is we developed advanced diagnostic tools using lasers to achieve better spatial and time resolution and to really understand better what particle beams are doing in a machine and in an experiment. A fairly large network, 4.5 million euros of funding that we received to train 19 research across the European Union. We have 36 partner institutions, so it's a fairly large network with regular secondments between the different nodes. The second one is even larger. It's actually the largest Marie Curie network in Europe across all disciplines. It has received 6 million euros of funding, and we trained 23 researchers on the optimization of particle accelerators, OPAC. In here, what we did is we linked beam physics studies where we described the motion of particle beams analytically, and in computer studies, we developed beam diagnostics again as a fundamental core of how to characterize a beam. If you can't measure a beam, you can't control it. So diagnostics really is fundamental to any accelerator. Our fellows also developed new computational tools, new software tools that allowed them to understand particle motion better, and advanced control systems that basically link between all the different parts. So OPAC even larger, 40 institutions, a very nice bunch of fellows as shown here, and you've spoken to them and enjoyed their poster during the last 2 hours. So both of them are combined here for the first time today in the 4-year period. So we have all the fellows here together talking about their research. The networks have been extremely successful. So we were evaluated by the European Union, and both projects were commended as European success stories, which I think is a very good sign for healthy research being done with and at accelerator facilities. We were specifically commended for the research that our fellows have been doing. So they're not only a nice bunch, they're also an intelligent bunch. They have been really doing very good research over the last 3 years, published a lot, went to international conferences, gave talks. We have established a new way of researcher career skills training via these networks, which is now used at universities across the UK, endorsed by the Higher Education Academy. We have done a lot of outreach, such as this symposium. We went to schools. Every single one of our fellows went to at least 2 schools and talked about their research, what they have been doing. They have been doing videos, which you can find on our website about their projects, very short 1-minute videos where you can get an idea in a nutshell of what they have been doing. That's me talking in Brussels at the European Commission in front of several hundred of other coordinators, because in Brussels they thought what we have been doing over the last 4 years was so good that they wanted us to share it with other people. So really what you have today here in terms of accelerators, and I'm also delighted that we have excellent speakers throughout the afternoon, is really, I think, some of the best research at the moment that you can find in this area. So for the afternoon, that's me with my introduction, and be curious, ask questions, benefit from the fact that the speakers are here. There will be a coffee break where you have additional opportunities to talk to our fellows, and in case you want to find out even more than what you learned today, there's all these various channels, websites, Facebook, Twitter, and the YouTube videos that I've just mentioned for you to find out even more. Thanks a lot.